here, but I'll be outside momentarily. Yeah, that's alright. It's pretty good. Trying a little bit with the Black Magic Pocket here. Oh. Get my face in focus. There it is. Sun's going down, so I'm losing my light pretty quick. But, hey Ringo. What you doing, buddy? Nice. Start here a little bit, see how this goes. Get some lights over here. There we go. Got some light. Alright. So, vlog episode 1, or whatever you want to call it. Here's what we got going on. So, I just got a thing. And I think this vlog, at least to start out with, is going to be guitar related. So, I'm going to start explaining this thing that I got here a little bit. And y'all can start to guess exactly what in the guitar realm I'm going to try and do with this thing. So, there we go. Got myself a lathe. Alright, let's walk around this way a little bit. Super basic, but it's got it where it counts, at least for what I'm doing with it. It is completely working. It's on this great bench, mounted already. I have all the parts to it. I've already started some work on what I'm going to transform this into. I would not call it a lathe. At least when I'm done with it, I wouldn't consider what it is a lathe. I don't think. I'm not exactly sure what they call it, but it's got everything here. Right? Got your spindle, drive. It's got pulleys here, belt driven. So it's got 4 different pulley diameters up top, and the corresponding opposite pulley diameters down on the bottom with this motor. The overall is that, you know, obviously they add up to the same pulley length no matter which placement you put the pulley at. So you don't have to change the relationship, distance relationship between the motor and this drive unit up here. Pretty basic old school lathe stuff. That being said, this previous owner, or perhaps whoever he got it from, I'm not sure, has this mounted on these hinges here. So the motor kind of bounces a lot and vibrates when it's running, at least right now. That's kind of what happens. So I'll probably hard mount the motor at the correct distance to this frame so that it don't get as much vibration, because that translates up into the rest of the bench. I think everything on this will be super solid and sturdy regardless of that, but it's just nice to not have that noise going on and all that stuff. Got some drawers, random stuff, you know, a couple wrenches for it. Got dead center, live center. There you go. Anybody that's used a wood lathe probably recognizes all this stuff. Got a faceplate, I guess, here. Really nice custom fit foam. Chunks of, I don't know. Anyways, manual, original manual. He also gave me a printed out scan of it, or a reprint that I think he got off the interwebs. So, yeah, everything's here with this thing. Runs, works. It's got a handy light switch to turn it on and off. This thing is super basic, but it's got it where it counts. All right. There's a lot of lathes out there First thing is it's on a workbench, which is really nice. It's already at a good working height. This bench is super solid. It's not going to really walk around or go anywhere unless I want it to. It's also cast iron. And this thing is probably from like, I don't know, the 60s. 50s or 60s, based on the model. But I wanted that. I wanted the cast iron because what I'm doing is I'm actually modifying this lathe. Anybody that's used a wood lathe will notice there's some stuff missing. It's not really missing. It's not missing. It's down here. This would normally mount up here, as with this adjustable end piece here. It sits on there, like so. But I'm not using those. Let's talk about that for a second, because that's where this comes into actually doing some guitar stuff that I think has not been done before. And we'll see how that goes. It's going to be a process. So, first things first, lathe, right? You don't think building guitars when you're talking about lathes. You think about turning stuff. You know, some people make bowls, chess sets. You know, they make the pieces, they turn them. Looks really nice. It looked like that's what the guy that had it before me was doing. Why have I pulled this stuff off of it? It's because I'm going to be adding to this in order to do some interesting stuff. So first thing I'm going to add is basically a linear bearing. Actually, a couple of linear bearings. So if we take a look at this here, it's got a pretty long bed. I think it's somewhere in the neighborhood of close to 50 inches. It's like 48, maybe 50 inches long from this point right here all the way to here. I'm going to be adding all along the length of that on either of these rails some linear bearings. And then I'm going to build on top of that, on the bearing rails, a sliding carriage that can slide the length of this lathe bed. And I was specifically after pretty much this lathe, or something similar to it. There's a lot of different lathes out there on the used market. I've actually been looking for several months. And the thing about this is, it's cast iron, right? This is not going anywhere. I can build onto this base and know that anything I add to it, within reason, certainly within woodworking reason, is going to be completely rigid and stable. Nice plus that it's already on this bench, so it's up at a nice, decent, more or less working height, and I don't have to find a table or build a table to bolt it to. Second thing I'm going to be adding to it is a gun drill bit, which will attach right here. All right, come along this way. So, gun drill bit. Drill bit for drilling guns, right? Especially like rifle barrels, longer barrels have to have a very special bit because you got to drill, if you think about it, an extremely accurate hole, an extremely long distance through an extremely dense, difficult material to drill or to machine, right? So you need a bit that can handle that. And obviously guns exist, so the drill bits exist. There's a few things that are special about them. First thing is the cutting tip is a specific geometry designed into it, has usually a single cutting edge and a geometry folding off of that that self-centers the tip of the bit. So that basically means it's not going to try and deviate a different direction into your material while you're drilling. It's going to naturally, as it rotates or as the workpiece rotates around it, either way you're drilling, it's naturally going to center itself. Second thing is that it's hollow. So it's hollow all the way through, and then the tip, the cutting tip, has a hole in it. And then it's a D-shaped bit. So it's round, but it has a flat on one side of it, along one side of it, all the way up the length of it. If you're doing metal, you would push fluid or pump fluid through the bit, which would come out the tip at high force while you're drilling. And then the only place for it to go is back out the hole in the gap between the bit and the wall of the hole, right where that D is, that flat is on the bit. So with woodworking, what I'll be doing is drilling, but not with fluid because that would mess up the wood. I'll be drilling with air. In this case, compressed air. Usually when you're woodworking, you do your removal of chips and sawdust and whatnot with air vacuum, so you have a vacuum system in your shop or whatever that pulls air and particulate with it away from the area where you're working. But there will also be a compressor running compressed air to push it into the bit and into the hole right where it's being drilled. So that comes to another important thing on this lathe, which most lathes do have this. There are some vintage wood lathes from like the 40s that wouldn't have this, so I was certain to check for this before I actually purchased the lathe. So here's what we got. It is actually hollow right through here. Let's see if I can show you. Yep, right through there. So the shaft is completely hollow, and that lets me attach that hollow bit to it and pass the compressed air through this hole. I will need a fitting for here that will allow it to rotate and pass the air, because I don't want to rotate my compressed air hose and tangle it all up really quickly as I'm going. So that's one thing I got to add, as well as the gun drill bit. If you've guessed what I'm doing already, congratulations. Now is your time to make your final guess, because I'm going to tell you what I'm doing with this setup that relates to guitars, and specifically electric guitars, is to actually drill guitar necks for the truss rod. And the way I'm going to do it is to drill into the heel of the neck, right? So I'm going to drill a hole starting there all the way through the neck till I get right to pretty much where the nut would sit, with a gun drill bit all the way through. And what that's going to allow me to do is to put a truss rod into a neck without mating two pieces of wood together in order to do that, which I don't think anybody's done before. Correct me if I'm wrong. If you know somebody that's done something similar, please let me know. I would love to talk to them about what they did and how they did it. This is what I've come up with, and I'm pretty confident that it will work. Astute guitar builders who are watching this will know that traditionally a truss rod channel isn't actually straight. It's curved from one end to the other, so that when you tighten the rod, it pulls against the wood of the neck and exerts force that bows it in the desired direction, which is back bow, right? That's how a traditional guitar neck would work. My goal is to install a truss rod without a skunk stripe, without putting a truss rod in and covering it up with a fretboard, doing neither of those things, true single piece of wood, unaltered, except for to drill in one end and then slide the rod all the way into the neck. So I'll be using a truss rod type that is not traditional, but it is pretty widely used these days, that actually does go into a straight channel or uncurved truss rod route. And that's a dual action truss rod, where you have your adjustable rod that adjusts in length as you rotate it, next to a fixed rod that is fixed in length at either end to the adjustable point of the adjustable rod. The benefit is that the two parts of the tension equation are both metal. It's a fixed rod and an adjustable rod, both metal. So when you get it curved or tensioned, adjusted right where you want it for your neck to be flat and level, it's much less likely to move on you. Whereas with a traditional truss rod, you have a single piece of metal that's exerting tension onto a piece of wood, which is susceptible, or much more susceptible, to temperature, humidity, all those climatey things that cause it to change, right? Because the wood changes in density and its ability to resist that tension, and therefore the curvature changes, and you get things like your guitar's out of tune, or in an extreme case, you're fretting out higher on the neck because it has a concave neck profile, or it's cupped or bowed in the wrong way. I already was decided on using a double acting truss rod just for the stability standpoint. Obviously, if you're a true to vintage tone fanatic and feel that the type of metal used for the truss rod or for your frets are gonna affect your tone in a way that you're not happy with because it's not true to vintage, obviously this method is not necessarily aimed at you. I'm trying to do something new and different. Once these necks are bolted onto the body, you're not even going to see any evidence of any routing or glue joints or breaks in the grain that would indicate that a truss rod has been put into that piece of wood at all. It's just going to look like one singular piece of wood. Traditional maple on maple neck, there's something about taking that to an extra degree of saying, this is really one piece of maple. There's nothing else added to this or changing it. All this grain came off of a tree and has been shaped into a neck and had a rod inserted into it, but the wood's not been split down its length or anything like that. It really maintains its integrity, which I think is pretty cool. The next step with this thing is really to call up a company in the metro here that does actual supplying of gun drill bits and accessories and whatnot. I've done some research online. I found a company that definitely makes a lot of the things that I need to be able to adapt to a wood lathe and attach gun drill bits and all those accessories to make this run nicely. And they have a couple dealers here in the metro that hopefully will be able to help me out and make sure that I get the pieces that I need to really make this work well and work flawlessly. Because the other thing with having a machine like this is that once it's dialed in and set up, I can just drill neck blanks. I can just do one after the other after the other. And that's the other thing that I'm hoping to get going, is to be able to make or manufacture these things, to a high quality standard, but also efficiently. That's pretty much it. Yeah, I think it's probably dark out. Let's take a look here, see what's going on here. It's probably pretty dark outside at this point. Oh yeah. You hear those spring peepers? That's what we call them here. I don't know what other people call them.
those little frogs that pop up in the ponds as soon as it's been warm for a week. Tadpoles. And then they just all go crazy. You can hear them all chirping away all at once. Hey, kitty.
It's the cat. Should we sign off? I think we should. Should we sign off? Alright, folks. I think that's going to be it. Oh, 2 kitties. 2 kitties. I think that's going to be it for tonight.
Hopefully that was interesting and not just solely me rambling. Anyways, till next time.